Alright, now we're on the final electronics paper. I don't know if the specification is different for this one. It might just be the same sorts of questions. Hey, the Four Fox. Do you know anything about electronics? Alright, it's my... Oh, the ink color has changed. Can't be having that. The rules specify you have to use black or blue ink. Yeah, that's more like it. Well, neither do I. I mean, I studied it in school because it was like a special topic that not many schools do, and is it? I mean, I can't actually tell. I'm colorblind. It looks like it was red, but now I realize it wasn't. It was. I thought it was still red from when I was marking it before. Okay, so yeah, electronics was an interesting subject because it appealed to those who did maths and physics. It tied in well with those topics because it, well, it used maths, and it even used calculus sometimes as well. I think at A level it used calculus. At GCSE level it was a bit easier, but sadly from 2017 they stopped this subject in the two main exam boards of the country. So actually not many schools do electronics anymore, which is kind of stupid because it's such an important subject. I mean, every year it becomes more and more important. You know, we're going more towards having electronics replacements for old technology and digital electronics especially. So not many schools do this anymore. I have to use this exam board now, EduCAS, which is a bit more niche, but I mean, it's still the same subject. Okay, so you get an information sheet, resistor color codes, a bunch of formulae. Half of these I don't know what they are. This one here, I think it's something to do with capacitance. I forget how that works. I used these two last stream without knowing what they mean, because I just saw the letters appear in the question. But yeah, it's a really good subject, and it's like industry level stuff. Like you could go away and become an electrician or electronics engineer using this material. So it's really close to actual university and industry level material. I don't know. The UK Education Board doesn't seem to care about electronics. Even in my day, my school was the only one in the area which was doing this subject. So, all right, let's get started. Start my timer. All right. Modern buses. I always thought buses would have two S, but now I realize it is one S. Yeah, that's right. Okay. Have a buzzer installed to warn people outside the bus that it is about to reverse. The microcontroller is fitted to the bus to pulse the buzzer when the ignition is on and reverse gear is selected, even if the bus is not actually moving. Oh! Yep, that's fine. Add these instructions to the correct boxes in the flowchart. So we want ignition on, reverse gear selected. So surely we just want to ask at the start, ignition on. Oops, ignition on. Yes. Then we continue. Reverse gear selected. Yes, then we continue. Then we switch on buzzer. Surely. Switch buzzer on. Then maybe delay. I don't know what they're getting at here. Why we have so many boxes. Delay and then switch off. And then delay. And then what happens afterwards to go back to start? Right, add links so that the program repeats. Okay. So surely after that final delay, we go back to start. If the ignition is not on, we go back to start. If the reverse gear is not selected, we go back to start. Surely. I don't see anything else we need to do. Alright, monostable produces a time delay of 4.3 seconds and has an output voltage of 9 volts when triggered. Initially, the out is at 0 volts. Complete the graph below to show what happens before and after a trigger switch is closed then released. Label the time axis with suitable values. I don't really remember this stuff. Oops. Alright, so I think it's like it's a delay switch. So you press it once and then it stays on for the set amount of time. So it basically catches like a signal but delays it to make it a longer signal. So it stays off until it's triggered. And then does it just go straight up to 9 volts? Or does it go up smoothly? I don't know. I think it just jumps to 9 volts. And stays on for 4.3 seconds. So 1, 2, 3, 4, 5, 6. So we stay on till 5.3. Then we go back to 0, I guess. I don't know. I think that's what happens. Following signal from a pulse generator is displayed. Time base is set to 5 milliseconds per centimeter, and the voltage gain is set at 2 volts per centimeter. What is the amplitude of this signal? So amplitude, so I think you treat this as being 0. So amplitude would be this height here. So 4 volts? Determine the space time for this signal. The what? The mark time for this signal. What? Space time? What's space time? It's gonna be one of these widths, so it's not gonna be the full signal, because that would just be the time period. So maybe it's the time that it's high. I don't know. So let's say 15 milliseconds. So let's say this is the space time and this is the mark time. I have no idea. Calculate the frequency of this astable. So we need the time period. Time period equals, so it's 25 milliseconds. Frequency equals 1 over time equals 1 over 0.025. So, 40? Hertz. Complete the design for an inverting voltage amplifier, but adding the required components connection as a diagram. Inverting voltage amplifier. Oh, I don't remember this. I remember you need some sort of feedback loop, so... The amplifier has a voltage gain of -40. So we need to take V in and multiply it by -40. I don't know. I remember something like, I don't know, you do something like this, and you do something like this, and this, I don't know. There's positive feedback and there's negative feedback. In this case, I think we want positive feedback because it's amplifying. What I don't understand is how you can ever get... So I know that the op amp produces either negative 5 volts or plus 5 volts. So this is always going to be plus 5 or negative 5. So I don't understand how you can get a voltage gain. I don't understand how this is even possible. Oh, let's have a look at the formula sheet. So it looks like we want to use this one. V out equals R2 over R1 plus R2 V in. Is that the formula? How do we decipher what that means in terms of the diagram? We need an R1 and R2. I mean, from this, we can say R2 over R2 plus R1 equals -40. So R2 equals -40 R2 -40 R1. So 41 R2 equals -40 R1. Wait, you can't have negative resistance. What? This doesn't even make sense. Maybe we should be using... I don't know. Let's just put something. What did I do? Like, I don't know, put that there. And this like this. And I don't know what to do with this negative. Let's say R2 equals... Oh, this doesn't make any sense. Say R2 equals 40 ohms, R1 equals 41 ohms, whatever. Alright, the power supply plus or minus 12 volts and the op amp saturates at plus minus 10 volts. I don't know what that means. The following input signal is applied to the op amp. Saturates. What is the amplitude of the input signal? 0.2. Calculate the amplitude of the output signal. So it multiplies by minus 40. So this will be 8 volts. So it would be similar, except it will go negative and down to 8. Following shows the gain bandwidth graph for an amplifier circuit based on an op amp. What is the gain of the amplifier at 10 kilohertz? Well, 20. We can see that easily. Determine the bandwidth of this amplifier. Show clearly on the graph how you obtained your answer. I don't know. I don't even know what bandwidth is, really. Is it the maximum frequency we can support before it tapers off? So, like here. So, 22. What is the effect on the bandwidth when the gain is doubled? Huh? When the gain is... Oh, I don't understand bandwidth. No, I think bandwidth, you're supposed to use this curve somehow. When the gain is doubled. That's the left-hand side. Whatever, I don't know, halved. Okay, this paper's horrible. I don't understand any of this stuff. D-type flip-flops. Okay, I used to understand D-types. Very useful component and can be used in a variety of applications. The following diagram shows a rising edge triggered D-type flip-flop connected to a digital data signal and a clock. Complete the output graph below for the digital data and clock signals shown below. The output is initially low. So it's rising edge triggered. So whenever the clock signal goes high, we look at the data. So right early on it's 0, so nothing happens. So the output is initially low. I believe it stays low for that clock cycle. This one it goes high. And then it goes low because there was another trigger. It stays low here because there was no data for that clock cycle. I think that's what happens. Pulse generator and a D-type flip-flop. The D-type performs a divide by 2 action on pulses from the pulse generator. Draw the 2 connections needed to do this on the diagram. Divide by 2 action on pulse. I think you do this. Hang on. I don't think I've done this right. I think I think the rule is when the clock is on a rising edge, D is copied to Q. And Q bar is always opposite of Q. So that's not quite what I've done here. So let's see. On the rising edge. So we definitely start out 0. And we stay 0 here as before. On the rising edge, we go up. So that stays the same as before. I think we stay high here. And now we go low. I think that's what we're supposed to see. So I think pulse generator, definitely we want to put it into the clock, I think. And I think we connect Q bar to D. So initially it's 0. This is 0 and this is 1. The clock comes in. And that's 0. And then 1 gets copied to... That's 1 actually. Clock cycle comes in like this. Pulse comes in like this. So then Q goes high. But now the next cycle, Q bar is now 0. I don't think this is working. So, let's see, that's the next clock cycle. That drops again. And Q bar becomes 1 again. And that gets copied across. Oh no, that's right. This is halved. Look, that signal is now halved. Instead of doot, 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 it becomes doot, doot. Alright, that works. I just didn't realize it. Okay. Frequency of the signal of the Q output is 100 Hz. What is the frequency of the Q bar output? It should be 100 Hz, right? It's always the opposite of Q. What is the frequency of the pulse generator output? Should be twice that. Divide by 2. Yeah. D-type flip-flop is a rising edge triggered. Label a rising edge on the pulse generator output graph. Rising edge. Q output is initially at logic 1. Okay. Complete the second graph to show the signal at the Q output. So it's basically what we had before. So Q bar is always opposite of Q. So on this rising edge, Q bar drops. And this will always be opposite. Another use of a D-type flip-flop is latch. Complete the design of a latch below so that the switch makes the LED come on, and switch SW2 resets the latch so that the LED goes off. Additional components can be added to your design as required. Latch. So I think we want to reset using R. So I think you do something like this. Clock. So you press the switch. That triggers the LED on. And it stays on. You press this switch. And that resets it. Is that what we want? Formula 1 style starting display for their model car racing track. The display looks like this. green light, red light. The race start sequence begins with all red lights on and all green lights off. The red lights then go off block by block. When they're all off, the green lights then come on. Okay, so we got all... Pulse generator, counter, logic system, lighting display. To turn a light on in the display... This is 1 mark to fill this whole table here. To turn a light on in the display, a logic 1 is required. Complete the following truth table to produce the necessary lighting display. Counter output CBA. Pulse counter. Isn't it the same? Aren't we literally writing the same table, but using counter instead of pulse? Which is the same, because the counter gets triggered by the pulse. Alright, so we do zeros, 1, 1, 0. Oh dear. 0, 0, 0, 0, 0, 1, 1, 0. So these ones, it's basically like this. You want 1, 1, 1, 1, 1. And then you've got ones here. And then all offs below. Block 4 output can be obtained using a single logic gate. Write down the Boolean equation for this output. So it's 1. It's not C, basically. The opposite of C. Block 6 cannot be obtained from a single logic gate. Write down the Boolean equation for this output. So it's 1 when C is 1 and A XOR B. Are we allowed to use XOR? I don't think so. So it's C and... Oh, no, that's not and. C dot A XOR B. How do you do A XOR B? I suppose A XOR B will be A and not B plus not A and B. Yeah. Complete the design of the pulse generator by adding necessary components and connections. 555A stable. Nice. I remember those. Oh god. So we got a capacitor? I don't remember how to use capacitors. Did we really do this at GCSE level? Maybe. 2, 6, 7. Oh, I don't know what these. I don't remember what these two. What number is which? 2, 6, 7. Okay, so clearly 1, 5, 4, and 8 are... We're not using them. 2, 6, 7. Posture. Necessary components. So 555 astable produces this, right? So don't you just need to provide it an on switch and it'll do the rest? So what do you need to do for 2, 6, and 7? But you need to be able to control the frequency. So how do you control the frequency? Is it an input? The capacitor? Alright, let's just assume the frequency is controlled by this voltage input to 2. 6 and 7, I don't know what to do with those. Just let's say 7 is high, 6 is low. I don't know. The red LEDs are driven from a transistor switch as shown below. The forward voltage drop VF for a red LED is 1.85 volts. Preferred value of R required to limit the current through each LED to no more than 20 milliamps. Oh, we need this formula up here. IC equals HFE IB. But we haven't been told HFE. What was it in the last paper? 100 and something? 200 and something? I don't know. This is a hard paper. Oh man, I'm gonna lose so many marks. Alright, I need to do a couple of things. I need to toilet break and I need to go open the window because it's hot in the room. I will pause the timer because what the heck, I'm not in school anymore. no invigilators to tell me what I can or can't do. Right, I'll be right back. Okay. So we know the current, well, we want the current here to be 20 milliamps. So we want IB to be 20 milliamps divided by HFE. I don't know what HFE is. What was it last time? It was 200 or something? No, it was a less round number. It was 40? No. 400? It might have been 400. Let's say 400. Well, are you meant to? But this is variable, isn't it? So they haven't told us what HFE is. I don't think. You can't just apply an HFE value, you need to know it. Or... forward voltage drop or red LED. I think you're not meant to use. Oh, this has nothing to do with the transistor. I see. Yeah, this has nothing to do with the transistor. So we need... So if 1.85 is there, 1.85 is there. So that's 3.7 volts. 3.7 volts across those guys. So that leaves 8.3. Is there no voltage? I don't understand how this works. Okay, let's say it's 8.3 volts across the resistor. So V equals IR. So R equals V over I equals 8.3 divided by 0.02. It's 415. I don't think I needed to use a calculator for that. 415. No more than 20 milliamps. Should we say 450 to be safe? Because they said no more, so they don't want us to be on the edge. I don't know. Alright, here's a design for a party light sequence generator using a 4017. I remember that. Decade counter. This is for making the 7-segment display. Connected to a 1 Hz clock. On the graph paper opposite, complete the timing diagram initially QO equals 1. Oh my god. 6 marks, alright. QO equals 1. So just... Is it not just... starts 0 and then... So Q0 is 1, and then won't it just stay 0 and then Q1 is now 1? And then Q, damn it, I can't draw. Q2 comes on. And then Q3. Q4, it's just in sequence, isn't it? Then Q5. Let's just say 0 is down there unless we specify otherwise, so. And then Q6. And then Q7. And then Q8. We don't have room. Have I done this right? 1. 2. 4. 5. 6. I think there's just no room for Q9. I can't draw straight. Oh my god, that was the worst ever straight line. Alright, well, red is 0 or 2. Red is 0 or 2, so it's going to be 1 here, and then there. Alright, yellow is 1 or 4. And then 4. And green. 3 or 5. Blue is 7, 8, or 9. Oh! Oh! Oh, tricky. Q6 is connected to reset, so that will reset the whole thing. Blue should never activate, right? So Q6. Alright, Q6. Alright, so Q6, go high. That's why 9 won't fit. Because it doesn't need to fit. So Q6 goes high. And then in the next clock cycle, it should go back to Q0. And then repeat after that. Like that. These guys just stay 0. Alright, so now, red, go back to these. So red is 0 or 2. So... Hello, Radian. Where is my shirt? Good one, again. Yeah, I do tend to wear this shirt for streaming. It fits in with a lot of my games. I don't know, military games or games where you're running around on some tropical island or something. So red is Q0 or Q2. So it will go high here. Do you know anything about electronics, Radian? Yellow is Q1 or Q4. And then blue will never go high. I think this is a trick question. Because it will reset before it ever gets to 7, 8, or 9. Circuit for a mixer is shown below with 2 test signals applied. 3 volts minus 5 volts. Calculate the output voltage of the mixer. Power supply is 10 plus or minus 10 volts, and the op amp saturates at plus or minus 9. I don't know. I don't understand op amps. I used to understand op amps. Have they just given us the answer for one of the earlier questions? Output voltage of them. So it's like an audio mixer. Okay, so... I think we have a formula for this. It just looks like it might be this one. V out equals minus RF, V1 over R1 plus V2 over R2. I don't really know what that formula means, but it looks like it might apply here. So what was it? It was V out equals minus R V1 over R1 plus V2 over R2. So equals minus 100 kiloohms times 3 over 10 kiloohms minus 5 over 20 kiloohms. Let's say, I'll make that 20, make that 6. So it'd be 1 over 20, so it'll be minus 100 kiloohms over 20 kiloohms equals minus 5 volts. Well, that's weird. That's one of the inputs. Doesn't sound right. Maybe it is. Op amp saturates at plus or minus 9.5 volts. What does that mean? Alright, so 3 over 10 kilo ohms. Maybe it's right. I don't understand what to use these things for. 10 volts. Improved design for the mixers shown below. Explain why this circuit is more useful than the previous design. Because the what is that called again? It's potential. I can't remember the name of that component. Let's say VR1 and VR2 give us finer control over the input voltages, the inputs 1 and 2, allowing us to decrease them as necessary, which reduces the contribution of either signal. So it's probably like an audio mixer. The VR1 and VR2 are turning the volumes down almost, something like that. I don't know. Shopkeeper has to walk down a dark path after locking the rear door of the shop. The student has been given the task of designing a system that can switch on a floodlight when the shopkeeper leaves the shop and stays on for a short time. Light should be operated by pressing a switch. Light should remain on for a minimum of a period of 4 minutes, then go off automatically. The student's design solution is shown below. 6 marks! Oh my god. I have no idea. At least this tells us what we... This is the last question. Let's copy this design for previous question where we had to fill it in. So it's like resistor, switch. I think that's the wrong way around. Shouldn't it be switch and resistor? Hang on, so switch, resistor, resistor, capacitor, 6 and 7. Let's redo this because I had no idea what this was, so... So let's say... we use switch for 2 and 6, 7. We have a resistor and capacitor. Wait, why do they have a capacitor there? Because I don't know what 6 and 7 are. They don't tell us, but I don't think you're meant to use a resistor capacitor like that because I think the A-stable, it already deals with the time period. It seems like he's using the resistor capacitor to create a time period. But that's what the 555 A-stable does. Isn't it? Let's have a look at these formulae up here. T equals, see, this one's important. T equals 1.1 RC. Frequency equals... That one seems relevant too, but I'm not sure. Alright, I need to finish this one off. Let's say that just connects to that, I don't know. I think I get it now. I think that is how you control the time period. Time period is what? We weren't told. 1 second, I guess. But we don't know, we don't need to know about Formula 1, but I would guess it's seconds. Let's say we want 1.1 RC equals 1. So R equals 1 over 1.1 C. Well, no, okay, C equals 1 over 1.1 R, so let's say R is I don't know, 20 kilo ohms. I'm just guessing something. 1 over 1.1 times 20,000. Would be 45 microfarads. All right. Anyway, back to this question. So time period equals 1.1 RC equals 1.1 times 220 kilo ohms times 100 microfarads equals 1.1 times, okay, 1.1 times 220,000 times 0.0001 100 microfarads, okay, 24.2. Which is 4 minutes. 4 minutes equals 240 seconds. So T is too short. Need to increase by a factor of 10. I don't think you should really go into the mega ohms. I've never seen that happen. Let's say increase that by 2 and that by 5. Alright, so that's one evaluation and change. What else? I think the resistor and the switch are the wrong way around. Shouldn't it be... Pressing the switch will just send 0 to 2, so... Switch and 1K resistor are wrong way round. This will just give 0 volt signal as is. Is that true? Maybe, I don't know. Floodlight 15 volts, 6 amps. Maybe the floodlight needs a resistor. Need a resistor in sequence with the flood light to maintain current, maybe. Floodlight needs 15 volts. Does the A-stable produce that? Yeah, I think so. Is this even the correct circuit for what we're trying to do? We're trying to make a monostable. I don't think... I don't know. I'm tempted to just leave it there, to be honest. I think that one was okay. Don't really know about that. Halved, I'm just guessing. I don't understand bandwidth. Oh, I think it's something to do with this curve. You're meant to take... gain bandwidth graph. We have 15 minutes left, but I can't be bothered to do anything else. Okay, it's not that many questions, but... yeah, I'm going to lose a lot of marks in this paper, for sure. Yeah, okay, I'm done. Let's... what was the timer, damn it? There we go. Alright, let's check out the marking scheme. Do we have the correct color pen? Very important. We need red now. Okay. Oh, wrong tab. We need red in the paper. That's where we're marking it. Okay. Alright, start. Is ignition on? Is reverse gear selected? Correct. I assume it doesn't matter which way around. Switch buzzer on, delay 0.5. Switch off, delay. Yeah, that's correct. Add links. So everything goes back to start. Yep. You're actually supposed to go to this arrow here, but it's equivalent. Alright. Yep, that's correct. 4, 15, 10. It was 6, 10, 15? What the heck? 3 centimeters times 2 volts per centimeter. Oh, so you take it from here. Why? This is the 0 axis, right? I guess... whatever. Nope. Nope. And nope. So I got space and mark the wrong way around. How does space and mark even reflect what they mean? Gotta pick better names for those terms. Alright, we lost 1, 2, 3 marks so far. Calculate the frequency of this A-stable, 40 Hertz. Yep. Okay, this I'm sure I got wrong. Oh? Yeah, I got it wrong. But not far off. I actually needed... RF from output to inverting input. RF from inverting input to input. RIN from inverting input to in. So I had neither of those. Non-inverting input to 0. No. No marks to be gained there. So that's 3 marks lost. Uh, 40 ohms, 41 ohms, that was... Gain equals RF over RN. Oh, I was using the wrong formula. I was using R2 plus R1, but whatever. So I was not far off. Actually, I was far off. Way far off. Yeah, no marks to be gained there. .28 volts. Correct. And then we want the sine wave with same frequency, inverted, correct amplitude. It doesn't say what it should look like. But I believe this is correct. What is the gain of the amplifier at 10 kilohertz? 20. 22 kilohertz. So gain of 0.7 times 20. I don't even know what this means. But appropriate lines drawn at gain. Bandwidth identified at 30. So you want... So you pick... Bandwidth is where you pick it to be 0.7 of the amplitude, whatever. I don't remember this stuff. Decrease by... Yes, I got those marks just by guessing. Decreased by half is what halved means, for sure. No one would dispute that. Alright, so I lost 3 marks. Well, I got 2 marks by guessing. Always guess when you don't know. That's correct. BI. Pulse generator to clock input, correct. Q bar to D. That's correct. 100, 200. Correct. Yep. Q output is initially one complete second. So I want that and that, correct? Alright, that went well. Alright, what's going on here? This one. So that is actually correct on the D and the clock. And then the reset comes from there. Wow, I actually got the setup correct. The only thing I missed was I didn't actually put values on the resistors. Let's have a look at this. D input connected, connected series, pull down resistor, junction of this one. It doesn't actually say you need to label the resistor. It just says pull down resistor, which is what I literally did. So I would say you don't need to actually label them. It doesn't really matter what value they are anyway. Within reason. Okay, I got this one right. I was half guessing here, but I was doing what seemed sensible. Nice, 5 marks there. 1 mark to fill this gigantic table. Yep, that's right. C bar. And then we've got that, and then we've got C. Well, they've used distribution. They didn't say what form they want it in. I'd argue mine is simpler form, but is it correct? C dot that plus C dot that. Yeah, so I've just used additive distributivity. I would say what I've done is completely fine. Right. Oh wow. Technically 2 is no. 6 is connected to the right place, at least. 7 and 2 are not. 2 resistors plus capacitor series, 1 mark. Orientation of resistors capacitors, 1 mark. Connection to pin 6, 2, 1 mark. Connection to pin 7, 1 mark. Do I get any marks here? See, I actually connected 6 correctly, but not 2. But they've lumped 6 and 2 together for 1 mark. So, orientation of resistors capacitors. What do they mean by orientation? As in, I put the capacitor at the bottom and the resistor on top. I think I got the orientation mark. I think I got 1 mark at least. And I got 6 but not 2. I don't think I can get the mark for that. But I got the orientation at least. So 1 mark. So 415, correct preferred value. Do not accept 390 ohms. Preferred value. I said 450. So what's... I think I'm correct. Like, what is the difference between 430 and 450? Either way, you just have to go a bit higher than 415. So I correctly identified 415, and then I chose something higher than that. I think what I did that correctly. Do not accept 390, which would be below. Where do these numbers even come from? So that's 25 below, and this one is 15 above. So I think they're just picking arbitrary values. So I think this is completely correct. Yes. Okay, I got 7, 8, and 9 right. So let's see. We've got go down there. Oh, I didn't get 6 right. So 6 instantaneously. Hello, the Full Fox. Welcome back. So I think I misunderstood this. So when 6 goes high, it triggers the reset for the D-type. So it will instantaneously go 0 again. So it shouldn't even appear on this graph. So it should be just like an infinitely thin spike like that. And then 0 should come next, and then 1, and then 2. Let's see how I can award myself marks here. So timing for decade counter. I got that correct. Reset observed at Q6. I think reset was observed, but I didn't get this mark because I got 6 wrong. And I based red, yellow, and green on... Oh, this is tricky. Total of 6 marks. Red, yellow, green correct, 1 mark each. Oh, I see. So I got timing correct. I sort of observed the reset. So I lost this mark here. Red, yellow, green correct, 1 mark each. So I got red wrong, unfortunately. I got yellow wrong. And I got green correct. But this is all because of the one mistake I made. But sometimes that's what happens. So I got 1 mark there, 1 mark here, and I would say I I should get a mark for observing the reset at least. I just handled it wrong. So 3 out of 6. Oh, that's annoying. I'll give myself 3 for that. I'm losing lots of marks. I think I've already missed the opportunity to get a top grade. Alright, minus 5 volts. Yes, I got it. Okay. It didn't look right. Different amounts of the input signal can be passed into the mixer because of potentiometer allowing anything from 0 to 100. I think I get 1 mark here, but I didn't mention the independence between the two. Alright, this one. Oh god, alright, so the student has correctly configured the 555 IC as a monostable, which we trigger. Okay. The time interval specified is 4 minutes or 240 seconds. Staging C would. So, yeah, okay, I got that correct. Don't see how I'm ever going to use this in the crabbing world. Well, you'd be surprised. I'm sure a lot of the fishing industry and crabbing industry are moving towards using electronics and digital components rather than the good old-fashioned ways. Alright, so I actually did this exactly correct, this bit. The output of a 5.5 timer is okay, I did not say anything about that. I did not say anything about that. And I didn't mention this, but then again, does it need to be mentioned? So I didn't get 5 to 6. Let's see, 3 to 4. Candidates have evaluated most of the specification, e.g. 2 of the 3 statements. Nope. 1 to 2. Candidates have evaluated little of the specification, e.g. 1 of the 3 statements. I think that's all I can award myself, 2 marks. Alright. 2 marks. That's another 4 marks lost. And that's the end of the paper. So overall I lost 23 marks. Much worse than the last paper. So get 57 for that. So my total mark, you know what they say, you're not always going to have a crabacus in your pocket. Good one. Alright, let's see what my overall grade was. So last time in electronics I got 66. This time I got 57. And then we need to find out what the actual grade boundaries were for that year. So overall for the two papers, I got 123? 1, 2, 3? Yeah, 1, 2, 3 out of 160. All right, moment of truth. I think that's probably a grade 8 or a grade 7. Not a grade 9. So this is the first time I didn't get a grade 9 for a paper. Let's see. So it was 2020, and I need to use Educas. So it's Educas 2020 GCSE grades. (2020). Here we go. Electronics. Maximum mark 160. Grade 9 was 133. So I missed the grade 9 by 10 marks. Grade 8 was 109. And I was comfortably within grade 8. Huh. So I got a grade 8. So actually, I exceeded my expectations. We could give that a color, let's say, pale green. So overall, I've actually still exceeded my expectations. F's in chat. That would have been funny if they still used the letter grades, but no, of course they've used this really bizarre numbering system, which is just confusing everyone now. The worst thing about this is it doesn't match 1-to-1. So A star doesn't match to 9, A doesn't match to 8. It's actually kind of disjoint. So there's no easy mapping from the letters to the numbers. It could have just made the map, but they decided not to. They just wanted to make everything more confusing. So people who are on the old system, it's difficult to compare them with people on the new system, for example, if they're in job interviews or whatever. So, what do I want to do next? Which paper do I want to do next? Biology? I'm predicting 5 for that. Shall I be a bit more confident? Shall I change that to a 6? Chemistry, I've forgotten a lot about. Geography, I think I might be being a bit pessimistic here, for biology at least. I reckon I could change that to a 6. Chemistry, I'm not sure. Geography, I think I could increase each of these by 1. I think I'm being a bit too pessimistic. Let's go with 6, 5, 6. I don't know, you didn't even get a 9 on electronics. But it was, regardless, I still exceeded what I thought I was going to get, which is an indication maybe my predictions are too pessimistic. But the problem is these numbers are so weird. I don't have a sense for what they really mean. Thing is, I got 7 as a kid, and I should logically do worse now than I did as a kid, because I didn't... It's a tricky one. I haven't learnt any more biology since I was a kid. Well, I have actually. But they do ask you really specific questions, you know, like what's this bone of this, what's this part of the skeleton cord or whatever. No, I think I'll change those back. Chemistry, I don't know. I think I'll do biology next time. But that might be in a couple of weeks' time. I don't have any time anytime soon. Biology will be interesting because I do actually have an interest in biology despite not being an expert in it. It's just the problem is my knowledge of biology doesn't coincide with the GCSE specification, because the GCSE, you need to know very specific stuff, you know, specific body parts, specific processes in the body. You know what? I'm going to change it to a 6. And same with geography. No. We'll leave geography at 5. Yeah, okay. I mean, electronics, I'm surprised I got that much actually, because stop being a pansy and go for all 10s. Would that I could. Would that there was even a grade 10. Well, that's another weird thing. Why do they go up to 9? 9 is really weird. Like, I bet some jobs, you show them your grade and they'll be like, oh, why didn't you get a 10? They might not even realize. It might seem like 9 isn't the highest. Because it doesn't seem like it is. Why 9? 9's such a weird number. Alright, I'll think about it. I think I will stick with these numbers. 6, 4, and 5 for geography. Alright, I need to get to the gym. Well, I hope you learned something, maybe. I'm not sure I learned anything. Still don't remember how transistors work, or operational amplifiers. Alright, well, anyway. They just save the 10s for the kids that they like. Maybe. I think, at least for maths, it wasn't even possible to get the top grade because there was... For the coursework, you can't get the top grade for the coursework. They only let you have up to, I don't know, 95% of the grade. They weren't able to award more marks than that. It's just some stupid system. Alright, see you later, the 4 Fox, and Radian as well, who stopped by. I don't know if you're still here.